we're just going to continue this on from yesterday, even though it was a recording from a year ago, but we're going to continue it on. Hopefully this sounds better than the recording for a year ago, as we kind of discussed a minute ago, because of having a good microphone now. So just to reiterate from yesterday, when you have 2 points, as you know from Algebra 1, you can find the slope and then use that slope in order to find the equation of the line that contains not just these 2 points, but the millions and millions and millions of other points. Yes. Okay. You were also not here yesterday? All right, so it gives you not just the equation of the line, but all of the millions and millions of other solutions besides just these two that go on. So just in case you had not fully got your head around that when you did Algebra 1, that's really what you're finding in all these things. So what we can do, though, is we can look at an example in real life. So not real life, but realer life, as far as what it could be used for. If you look on page 139, there is an example that I would like to talk to you about. So turn to page 139, and as you're doing that, I'm just going to recap it for those that are not right here live with us, and write down a couple things from it. And it talks about how that the participation in U.S. lacrosse, and there was a survey about that, and that in 2009 there were 300,000 players. So in 2009 there were 300,000 lacrosse players. And how in 2013 there were 400,000 lacrosse players. And so what they wanted them to do, what they were asking for, is an equation that would represent the growth in the sport. Okay? Whatever the questions are, you can or raise your hand to ask. Asking you for an equation to show the growth in the sport. So sometimes what we can do is we can make ordered pairs out of data and then use that same process from a minute ago as far as writing an equation. So rather than saying 2009 and 2013, it's more convenient to represent the 2009 as a 9 and make an ordered pair out of that. And then also we'll make one ordered pair out of the 9 and the 300,000. And we'll make another ordered pair out of the 13 and the 400,000. And we want to use that same process from yesterday to find an equation. So to find an equation, we need to first find the slope, right? And how do we find the slope out of these numbers? Do you use y2 minus y1 over x2 minus x1. So on our problem here, we need to label. So we'll use x1, y1, x2, y2. And we need to fill in those numbers. You said y2 minus y1, so 400,000 minus 300,000 over 13 minus 9. So we get, how much is 400,000 minus 300,000? 100,000 divided by 4. And so how much is 100,000 divided by 4? 25,000. So 25,000 players. 25,000 is our slope. And when we really think about that, that's the rate of change per year. But we need to make it into an equation, so we want to think about our mx plus b form. So y equals mx plus b. I want to get a bigger drawing thing here. Y equals mx plus b. And we can pick either one of these to be our starting y and x. So let's pick our 300,000. And what's our m? 25,000. And what's our x? 9. Plus b. Some of you might know other ways of solving for this, but we're just going to do this one. So how much is 25,000 times 9? 225,000. Plus b. Then take away the 225,000. That gives us 75,000 equals b. So our final equation is y equals m 25,000 x plus 75,000. And then just to think it through as far as what these things represent, okay, 25,000 represents what? Sorry, 25,000 represents well, we're taking really a change in the number of participants in lacrosse divided by the number of years that happens. So the 25,000 represents the change in number of participants per year. So it's going up by 25,000 players per year if it follows this continual pattern. Now the one thing with statistics is that sometimes it follows the pattern linearly like this, sometimes it follows it in other ways, and sometimes it doesn't follow it at all. So you can use these type of things to make a prediction, but then what analysts are actually doing is then they'll use other data to see if maybe there's some kind of a change in that prediction as far as what would be coming through. So really what this means is that in year 0, which was really 2000, okay, can you understand how that would be? 0 would be 2000. If 2009 is 9 and 2013 is 13. So in year 0, that means if we plug this in, there were 75,000 young lacrosse players. And then it was growing and growing and growing from then. I don't know if that trend has continued or not, but it's kind of neat to think about that people can study all kinds of things, whether it be lacrosse or whether it be something else. Okay. So that's our example from word problem type of a thing. And then you have this on your paper about finding an equation of a line, but we're going to be adding quite a few things to this. So please make sure that you have this in front of you. You're going to find the equation of the line first of all. Notice there's a point P off the line, so we're going to be adding quite a few things to this. So what was our slope-intercept equation again? Y equals mx plus b. So we need to be able to find our m and find our b on here. First of all, what does b represent? Y-intercept. So Nico, what number is the y-intercept here? 1, because it crosses at 1. So b equals 1, and then m is our slope. We can count a slope from your equation, your graph that's right in front of you on the paper. So it's, if we go from here to here, we're going how many down? 2 down, 1 over, so our slope is -2. Just from that information, knowing that b is 1 and the slope is -2, you can go straight to the equation from that. Down 2, right 1 gives you -2 for your slope. B is 1, that's your y-intercept. So our equation is y equals negative 2x plus 1. So straight from the line, you can get that equation. But we're going to be adding some questions, so you have some room on your paper to put down below so that we can add the questions. You might not necessarily want to write these all on the graph, but maybe on the white spot below where there's nothing, so that we can add to the graph when that's needed as well. Okay, because I want you to add a question to this. I want you to add the second part that says find the equation of the line parallel to, that says parallel to it, that goes through line P, parallel to K. The line is called K. So we want to find the equation of the line parallel to K that goes through point P. Parallel to K that goes through line P. So we want to write that question down so you know later what it is that we have found. And then we're going to graph it. That's why I didn't want you to write directly on the graph. So what do we know about parallel lines? What do we know about their slope? They're the same. So once again, what was the slope of this line? Negative 2. So our slope has to be the same when we find an equation of a line parallel. We also know the ordered pair that goes with this point, P. What is the ordered pair that goes with this point, P? What is it, CJ? Negative 1, negative 3. Good. So negative 1, negative 3 is our point, and we want it to be parallel, so we want it to have a slope of negative 2. So we're going to go through this process one more time using the slope of negative 2, so it's going to have an equal slope, going through the ordered pair negative 1, negative 3 to find the equation. So what I want you to do is what we just did a minute ago, is I want you to use your y equals mx plus b. What number are we putting in for y? Negative 3. Nico? I'm sorry, say again. Okay, so somehow on your paper that you have, I don't know how that happened. Somehow on the paper that you have, your point P is showing up at 1, negative 2. So thank you for pointing that out. So what I'd like you to do is I would like you to move that point to 1, negative 3. So please move it. And I really honestly have no idea how that happened. So cross out that original point P that's on your paper that's different, that's up here. As I said, I don't know how that happened because I actually literally printed it off of this, so I'm not quite sure what happened when that was made. So we're down at negative 1, negative 3 on that. Thank you for moving that down, everybody, because So if we're going to actually move that at negative 1, negative 3, let's plug in our values. Negative 3 goes here. What goes in for m? Negative 2. X gets negative 1. Then we do your little bit of algebra to solve for b. Multiply negative 2 times negative 1 and get positive 2. Then how do you get b alone? Subtract 2, and that gives you negative 5. Good. I was hoping to hear the right answer on that one. So negative 3 minus 2 is negative 5. So our equation then is just y equals negative 2x minus 5. And this is the equation of our line parallel. So what I'd like us to do then is I'd like to actually graph that and make sure that it works, make sure that it does produce a parallel line through that point, -1, -3. Get a chance to make sure you've got that right written down. And so we're going to graph it. Y equals -2x minus 5. So we start at 1, 2, 3, 4, 5. -5. And then down to right 1. But then also up to left 1 also gives you that same number. And then we have that line. If you draw that in, down to left 1, down to left 1. -5 hits that same point that we were expecting. If your ordered pair is at -1, -3. So I do want you to sketch in this graph. And then we're going to add another question on there.
Wait, it goes through P.
Yeah. It goes through P. Because our equation, what's the matter? It goes through P, but as I said, somehow on your paper it got printed out at the wrong spot. So this is actually point P. This is wrong. So this is point 3.
Oh, so I have
And then,
to
yeah.
Oh,
So you had this part right. Yep.
All right, man.
That was something wrong with the printing, which anyway, so we have this. It does come out to be parallel. Notice that you can very easily imagine going on forever and never intersecting. So the one last question that we want to write down, though, is what about if we want to make the equation perpendicular? What if we're at the same point P and we want to make the equation of the line that's perpendicular to this and go through? It would end up being perpendicular to this one and also this one. So what's different about perpendicular lines with their slopes? Yes. Opposite and... So the opposite, yes, but it's kind of like also... Good, exactly. The opposite reciprocal or the negative reciprocal. So we're going to find the equation of the line perpendicular to K that goes through P. And I know that you're writing that in. Perpendicular, and then we'll go through those steps for that. Just as we get started, though, I need the negative reciprocal of the slope. So what is the negative reciprocal of our starting slope? That's almost right. That was the reciprocal. That's still almost right. The reciprocal is 1 over -2, but you have to make the opposite of that. So what's the opposite of -1/2? 1/2. Yep, that's it. Somebody said 1/2. So the negative reciprocal not only flips it over, but it also makes the negative into a positive. So we're going to need to use that, the negative reciprocal, to get our new slope to go through point P, and then do the same thing to find the perpendicular line. So y equals mx plus b again. Same ordered pair, different slope. That's the negative reciprocal. Turn it over. So plug in your y, plug in your m, plug in your b. And when we solve this one, we do get a fraction, but that's okay. We get -2.5 is your b. That's your y-intercept. And then you write the equation. You can have a mixed number or a decimal come into it. So y equals 1/2 x minus 2.5. And we are going to check to make sure that this makes sense momentarily. If you could all just write this down first, and then we're going to check it. What I want you to do, if you've finished writing down the work for this, I want you to go ahead and plot that on the graph to make sure that that makes sense and that you are getting a perpendicular line that goes through P.
Miss Dottie,
Mm-hmm.
please get 3-2 because I lost it. Like, can you just get it to me?
All right, so let's take a look at what it looks like graphed. When I use y equals 1/2 x minus 2.5, you can go down 1, 2.5. And then you can go up 1 over 2 from that. Up 1 over 2. And it's going to land right here.
Wait, Mr. Can you check this for me?
In a minute, yep. So here's our negative 2.5. Up 1 over 2 actually lands here. Or you can even start from P, up 1 over 2, up 1 over 2, and we end up with those things. All doing the same thing. Negative 2.5 is our y-intercept, and up 1 over 2 is our slope. And this is where I'll end the recorded lesson for today, and we will then do this. Hello to the girls in Canada. Hope everybody's doing great. Saw the game yesterday. It was good. Miss you. Bye.